Hi guys, welcome to Code Decode. So today we are going to cover a very important Java interview question, which is what are design patterns, what are categories of design patterns, and how do you use these design patterns in your current application or project. So let's get started without further delay. The very first question that may arise to you is what are the categories of design patterns? So we can say that we can broadly categorize all the design patterns into four basic broad divisions. The first is creational design patterns, how the objects are created, behavioral design patterns, structural design patterns, and J2W design patterns. I'll be focusing on this particular part in this particular video, and if you want me to cover all the three remaining parts, please let me know in the comment section. Then only I'll be creating videos on the three parts of design patterns. Currently we will be focusing on creational design patterns. So let's get started with them. So before we get started with the creational design pattern, the next very important interview question may arise before going into deeper into those particular things is why do you actually need design patterns? So we know that we can find a solution to any of the solutions by our own. We are great enough for that. But why do we need these design patterns? So first of all, design patterns are actually solutions to some specific issues. Like I want that my complete project has one single object and it should not create multiple objects. Then the solution to that is create a singleton design pattern. So design patterns are nothing but a solution to some known problems. So why do we need design patterns is actually related to that only. So these design patterns are documented and understood by software architects, engineers, developers, and designers. So all the applications remains their solution specific, and likely we will be able to understand each other if we are going to talk in the terms of design pattern. So if I say you I want to have the singleton design pattern, then everybody will have the design pattern of singleton type, as in a single object being shared among various applications. The second reason why we need design pattern is that these design patterns are actually nothing but a tried and tested solutions to some common problems. Thus it reduces the technical risk. If I come up with my own solution, there might be some technical risk, and the project may have to deploy a new and untested design. To prevent this, I'm going to use the design patterns which are actually tried, tested, documented, and they are very common to those problems. Thus, it saves your time and effort during the development stage or the implementation stage of software development lifecycle, SDLC. The third important reason is that they are language neutral. It's common to all the languages which supports object oriented, though it is C++ or Java or any object oriented languages. And since it is well understood and documented, the final product, that is whatever I'm going to create as a Java application, has much more higher degree of comprehension, and the solution is easy and extendable. So this is why we are going to use design patterns throughout the Java application, so that these are the tried and tested solutions to some common problems. Now, this was all about theoretical way. From now here onwards, we will be focusing more on programming way, because they might ask you to write some code snippet to make sure that you actually understand these design patterns. So let's get started. As I've told you, we are going to focus on creational design patterns. Creational design patterns, what are these creational design patterns? These are nothing but a way of creating objects. Like, this is creational. So how do you create your Java object is what is covered under these broad categories of creational design pattern. Say for example, this I'm creating an object with a new keyword. So this is a type of creational design pattern where the new keyword is used. Now these creational design patterns are basically divided into five major parts. First is a factory method. Second is abstract factory. Remember, when we come to abstract factory in builder, these are very complicated, so you make sure that you have a full concentration on these two. Then we have prototype, and this is the simplest part, which is the singleton the creational design pattern. So let's first get started with the factory design pattern. So before going into theory, let's not make it very boring for you. Let's do one thing. Let's understand the flow chart and let's understand the code, and then we will come to theory so as to have a better understanding of it. So what this factory design pattern says, it says that I don't want to expose the creational logic. Like, how am I creating the object? I'm creating it using new, I'm creating using AutoWare. I don't want to expose that to client. So how do I do that? So the method is, we can do this with a factory class. So this is your client or the main class. This is your factory class, which actually the client interacts with, and in like behind the screen or behind the curtain, this particular factory class is responsible for calling a particular or creating a particular object. So now I'll be showing you the code snippet for this design, this particular design pattern, factory design pattern. So I have created this particular thing for you. So I have told you that we have, suppose I have a particular profession, which is my interface. My profession can be of three different types. I can be an engineer, I can be a doctor, I can be a teacher. So how I am going to denote this in my programmatical way? So profession will be an interface, and I have a particular method, say print, which will print what I am actually. Then I'll be implementing this interface in my different concrete classes, say doctor. So doctor will print, I'm in doctor class, engineer will print, I'm in an engineer class, and teacher will print, I am in the print class of print method of teacher class. So this is how you implement your interface with the different concrete classes. Now what factory pattern says that I want to create an object of doctor or engineer or teacher, but I don't want to show you how am I creating that object. So what you have to do, you have to create a factory for it, as the name suggests. So what does this factory class do? This factory class does nothing but takes a type what you want to have. Say I want to have a doctor. So if you say doctor, it will give you a new doctor. If you say engineer, it will return you a new engineer. If you say teacher, it will return you a new teacher. So suppose this is my main class, or what you can call it, this is my client. So what client will do, it will create a factory object, and what it will say, I want to get a doctor. So it will say profession dot get profession doctor. So what happens in the underlying behind the screen, the factory method, this particular get profession get called, and it says okay, this is doctor, it matches. See, it was doctor, yes, it is doctor. So it matches, and when I try to print, this particular new doctor object is created, and this object is returned. So as soon as my profession doctor is returned, the print method of doctor will be called, and it will print in print of doctor class. So let's see if this particular whole thing works or not for me. So I'll do run as Java application, and it says in print of doctor class. It does not print any teacher or anything, right? So did you understand this particular Java concept? We have one interface profession. We have three concrete classes implementing that interface, which says in what particular class I am. And I don't want my client or the main class to see how I'm creating. So I don't want to create my doctor class with a new object. So what I will do, I will create a factory rather, and I will create a factory object. So I've created a factory object, and I'm saying factory, go and bring this particular thing. So I'm saying go bring a doctor. So the factory is going behind the scene, and it is creating a new object. However it creates, I don't have any problem. This client does not know whether this factory is creating an object with a new keyword or with the auto wiring thing, but it is returning me doctor, which is what I want at the end. So consider this as a real-time scenario. You are the client or you are the customer. You are going to a factory and saying go bring toothpaste. Now how that toothpaste is created, with what chemicals, with what substitutes or ingredients, it doesn't matter to you. What matters is you are getting the thing, right? So this is as simple as factory pattern. What happens there? A factory is there, a client is there, client creates an object of factory and says go bring this. How it is going to create the object, it doesn't matter to this client. So that was the factory pattern. Let's go to the theoretical part. It does not expose us the creational logic, right? It does not say it's created with new or auto wiring or anything. It just gives you the created object using the standard interfaces. And it is also known as virtual constructor because you don't know how the object is created. So the two simple steps: create a main class which calls the factory class, and factory class in turn returns the required instance. Simple two steps. Okay. Now let's continue further for the abstract factory pattern. Now understand, this is difficult part of it because it is like factory of factory. I don't want that I should go to factory and I should get the particular object. What I want is I'll be creating factories of factory, and then I'm going to get the data. So I'll give you a real-time scenario. Say suppose there are two type of professions, okay, engineer and teacher, but there is also one more type of profession, abstract type, which is training engineer and training teachers. These are those who are still not completely engineers, they are not complete engineers, they are still having the training phase of learning, or learning phase or training phase to become an engineer. And also they have a teacher who are not full-fledged teachers in their role, but they are in training purpose to become a teacher. So what I want is, like, I have four classes basically. The profession is similar to this, an interface or abstract class, which has the teacher, trainee teacher, engineer, or a trainee engineer. Four type of professions I'll be having. And then for creating the full-fledged engineers or teachers, I have a factory. So this professional factory creates professional engineers and teachers, but trainee abstract factory creates trainee engineers and trainee teachers. But above both, I have one factory, which is what I'm going to interact with. So it is as good as I go to a particular factory, I say, give me toothpaste. Now there are three different type of factories, which are intermediate factories, which actually gives you the real object. So this is like intermediate phase. This particular phase is intermediate phase for you. I go to this producer, the producer actually goes to the factory, the required factory gives you the object, and this is something you get at the end. So you get the real-time scenario, you go to a factory, the factory goes to the second tier factory or the intermediate factory, and that actually internally gives you the real object. Then that real object gets back to your the third party factory, then to the factory where you went, and then you get the real data. So let's see the code for this particular implementation. It's a bit typical one. Please stay with me. What I've told you, I have an interface profession, same like before. Now I have four basic concrete classes. I'll have teacher, which says I'm in a teacher class. I have a trainee teacher, which says I'm in a trainee teacher. I'm not full-fledged teacher. I am still a training. I'm still in training phase. Then I have engineer, which says I'm in engineer class. And then I have trainee engineer. It says I'm still in the training phase. I'm not full-fledged training engineer. Now, you know what we did in the previous one. We created factories. So there will be one factory which will create professional engineers. So this is type of profession. If you say engineer, the new engineer will be called. If you say teacher, the new teacher will be called. But there will be one more factory which will create training people. So if you say engineer, it will return you the engineers which are still in training phase. And if you say teacher, it will return you the object of training teachers, which are still not full-fledged teachers. Now, above all those, if you can see, it extends the abstract factory. So what is this abstract factory? This is nothing but it says that get the profession. So it is just an abstract class. So this is like just the way what you want to do, the abstract one. And this is the producer. This is where you went. This is the main factory where you went as a client. So what it says, you say, do you want a trainee? If you say yes, you want a trainee, you will get a trainee factory. If you say no, I don't want a trainee, I want full-fledged professionals, you will get a full-fledged professional factory. And this factory, you already know, returns you full-fledged engineers. And if you say trainee factory, if you say yes, I want trainee, it will give you the factory which will create the training engineers or trainee teachers, but not full-fledged people. So this is the main method. So what main method will do? Main method will create a basic abstract factory using the producer. So this is where you went as a person. As you say, this is an abstract factory producer. You say get profession true. So what does get profession says is, do you want a trainee? I'm passing true. That means I want a trainee only. I don't want a full-fledged professional. So it says yes, I want trainee. So what will happen? You will this particular producer will go and talk to trainee professional factory. And what this trainee professional factory will do? It will give you trainee engineers or trainee teacher based on your requirement. You want engineer or a teacher. So let's get back to the main method. This is my main method. Main method will create a producer's profession. You say yes, I want trainee. It will give you the required factory, and with that factory you say give me engineer. But since you have given it to trainee, so you will get a trainee engineer. So if I print, it should not print that I am in engineer class. See, it should not print I am in engineer class, because I have passed it as true. True means get profession true means I want a trainee. So what it should say, it should say I am in a print trainee engineer class. So let's see, are we able to follow this particular thing? Let me run this thing for you. It should say I'm in a trainee engineer class. It does not say I'm an engineer. Why? Because you have asked your producer to go to such factory where your profession, you won't develop a real professional people, you will develop a trainee professional. So this is how you abstract your even factory. This is double layer abstraction, where you have a factory for factories also. So you have two factories. If you can see, this level is only one level of factory, the one we have covered earlier, the factory pattern. But this producer is two level factory, because this is factory of factory. Now you get the point. Let's get back to the overflow, the flow chart. You have engineers and teachers, trainee engineer, trainee teachers, professions. Now this full-fledged trainee and teacher is provided by this one level factory, and the trainee engineers and trainee professions by trainee factory. Then this is the parent of both, that is okay. And this abstract factory producer is the client, is the real factory, and you are the client here. So here you say main class, you are the client. You says, you go to a particular factory, you say give me this particular thing. Then this factory actually in turn gets into touch with the two different type of factories. Now you say that I want trainee only. So if this particular path is removed, you get to the trainee path, and then you say that I want engineer. So you will not get the full-fledged engineers, because you have chosen a trainee factory, and the trainee factory will give you trainee engineer, and then you get the trainee engineer. So I hope this particular thing is clear. Now I'll go to the theoretical part, so that you will be able to understand it better. This factory is also called factory of factories. This is not simple abstract factory, it is factory of factory. So it lets a class return a factory of a classes. So this is the reason abstract factory is one level higher than factory pattern. Now I hope this is very much clear to you. If you still have doubt, I understand this is complex topic, please let me know in the comment section. I will give you more real-time scenarios. Now the interview may ask you the steps, so you can just say that create a client or the main class. You can call the factory of factory class. That means the real factory where you stepped into your legs into the factory. That factory in turns intermediately behind the screen calls the required factory class using the producer. This producer was your client. This producer was your factory of factory, or the real factory in which you do, and you are the client. And this actual in turn returned factory to this factory of factory is nothing but a class instance. So there are basically three steps. Initially we had two steps: create a main class, call the factory, factory gives you instance. Here you have three steps: create a main class, call the factory of factory will call the factory, and then factory will return you the instance. So can you see the third layer between it? That is why it is called as factory of factory. Let's go to the third important design pattern, which is a singleton design pattern. This is the simplest design pattern for you, so I'm not going to create any steps for this. There is one single way, with one single shot you will be able to understand it. Singleton design pattern says that, I'll go cover the theory first so that it is easier for you to understand. It involves a single class which is responsible to create an object, one single object, making sure that only one single object is created. So what is the purpose of the singleton? Only one single instance should be present in whole application. And this provides a way to access its objects, which can be accessed directly without the need to instantiate the object. How do you instantiate object? With a new keyword. So this way we design a class in a particular way that we only access a object directly without having a new keyword access to it. So there are three simple steps what you have to do to make sure that your all the classes are singleton in your Java application. What you have to do, for the particular object that you want to be singleton, you have to create the singleton instance like this. The new keyword is used once, but this is private in nature and static. Hence, this particular singleton instance will be loaded and will get memory as soon as your class will get loaded in the memory the very first time. And n number of times you try to create object, though you cannot create object, but n number of times you try to load this, every single time, only this, since it is static, only one time this instance will be loaded into the memory. So this makes sure, making it static, that only one time this particular singleton instance get the memory. Now making it private, make sure that you cannot access it directly. How do you access it? You access it using a get instance, but you don't have a setter. So what you have to do, make a singleton instance with a new keyword. Second thing you have to do, create only getter, no setter. And third thing, you have to make the constructor as private. Why? So that you cannot instantiate this class object using the new keyword. So as simple as that, 3 simple steps. Create, this is eager loading. What will happen in lazy loading? You, in the get instance only, you check if instance is present. If not, then create using the new instance, else return the existing instance which is present in the memory for this Java application. So I've shown you the eager one. For the lazy one, you can go back in my previous videos, you will find it there. If not, then just let me know, I'll create again video for that. So 3 steps. Create the private static variable with a new keyword once. This instance will get memory only once since it is static. Create the private constructor. Create only getter, no setter. How do I test that? You just have to create a singleton object using the get instance method. You just getter. I just have a getter. I don't have a setter. So with this simple method, you get a singleton object, and as this was simple method, hash code. How do I make sure that you understand that is a single instance? So I can make that to show to you is that you can see that I'm creating the hash code, right? If you can see, this is the hash code. I'm just printing it directly. So printing an object directly actually prints the hash code of the object, because I don't have equals and hash code implemented, right? So let me run this particular thing and I'll show you how it should work. So it says, just a second. Okay, if you can see, I'll put this main method here. The singleton object is created, and again singleton 2 object is created. So these are 2 different objects, right? If I would have created with a new instance, like I would have created the teacher instance, 2 new objects, so the hash code of these teacher will be different. So if you can see, the hash codes are different, right? But when I go to this particular singleton.get instance and then simple method and I print it, this simple method nothing but prints the object the way it does for the teacher. It says it's the same one. So this is how you can make sure that the memory is given only once to all the singleton objects. If I print it 10 times, the 10 times same thing will happen. You can try it by your own. But this is how I can make sure that I have implemented the singleton thing. 3 steps, remember. Private static new keyword once only, private constructor, and only getter, no setter. 3 steps and you are done with singleton. Now let's proceed further towards the prototype design pattern. So prototype design pattern, just remember one important thing for this particular prototype design pattern. I'll show you again with a diagram. Main class, this is your client. It will call your cache. So first you need to understand why are we using this particular prototype design pattern. We are using this to just remove n number of calls to creating a new object. Rather, you just want to duplicate the object using the clone method. So as soon as somebody asks you what is prototype design pattern, it should click to your mind that it is nothing but a way to create a clone of an object already created. And hence, why do you create a clone? Why not new keyword? Because there might be some cases where creating an object with a new keyword or some another way is very costly. So now interviewer will ask, why is new keyword that costly? So you may ask that there may be two or three more chances. Like if suppose the new keyword is creating objects with causing the database calls. So you know that database calls are very costly. N number of calls to databases will cost you n number of money. In terms of monetary terms, you will lose. Hence, when you don't want to create new objects again and again, you will use a prototype design pattern. How you use it? Using the clone method. So few simple steps. There is one. First, you create a client. Secondly, you create a cache. So this is a static cache. As soon as you call this particular thing, a cache is created. it returns you the instance of a cloned object stored in that cache. Now I'll again take you to the same example, profession, engineer, doctor, teacher, so that it is easy for you. So let's go to the prototype design pattern. Remember, it involves a cache. So before getting into cache, again I'll make you go through it. A profession, it's nothing but an abstract class. Now this is not an interface. Why? Because this profession main class will actually implement a clonable, and it will give you a method how to clone an object. So profession says ID and name. Why? Because cache is always key value pair. Otherwise how will you tell which profession is stored at which particular key or in the table? So that is why profession, the main class will be the abstract class. It will have the particular abstract method, but a concrete cloning method. So cloning says whatever comes here, I should clone object, and using the clone I should return its super.clone. Super is nothing but clonable. So what you will do, you will just return a cloning object. It will have ID and name. So ID for doctor will be this extends the profession. The profession does not have the print elaborated, hence I've written in doctor. This is as same as that I've already shown you, engineer and teacher. Now this is your client. So what the two steps the client will do. The first step, it will call the cache. So as soon as your cache is called, what caching class consists of is a private variable map. Map is nothing but a key value pair, and this map will have nothing but the creating the object using its ID and putting into this map. So as soon as my client calls this load profession method, this load profession will do nothing but it will create a map for me. So by the end of this thing, you will be able to understand that my map is created with three different objects, key value pairs, that is 1, 2 and 3. 1 will have doctor object, 2 will have engineer, and 3 will have teacher object. So this, because it was costly thing, so that is why only once we are doing this particular new object creation. Second time, what my main class will do, it will try to from that cache to get the profession using the key. So if I do 1, it should return me a doctor. When I do 2, it should return me engineer. When I do 3, it should return me teacher. But I was not sure whether with again 1 doesn't it return the same object. It should not, because I want a new object to be created. I don't want a singleton type. So that is why I tried in printing the hash code, and if you can make this run, you can see the hash codes are different for both the doctors. That means that why is it different? Because a clone is created every time you try to get a ID. See, so when I try to get, how do I get it? Profession.get clone. So get clone you will pass an ID, so it will get a particular instance, but before returning it, it does not return the cached instance. Rather, on that cached instance, it calls the cloning method. What cloning method do? See, I told you why I have not created the profession as interface. Why? Because it gives you the cloning method. So it gives me the cloned object of that particular profession. Now profession is an abstract class which is parent of doctor, engineer and teacher. So all the three will be cloned using the same method of cloning defined in the parent. It is inheritance, nothing else. Simple concept of inheritance. So if my client wants a particular profession of doctor, it will send 1, but it will get the object of doctor profession, even not the same one that he has got the earlier. It will get the different because the clone method is used. So this was all about prototype design pattern. I'll make you go through once again through the theory so that it is easier for you to understand. It creates the duplicate object or cloned object, keeping performance in mind. It involves implementing prototype interface, which will tell you to create a clone of the current object. So who will create a clone? This particular object, the profession creates the cloning method, and the cache will actually create the clone using the cloning method call to that instance. And this pattern is used when creating an object directly is costly. Like new object creation is costly. Why? There can be two scenarios. The interview may ask you, when can you say that the new object creation is costly? We can say that new object creation is costly when you involve the database calls, because each database calls gives you some monetary losses. And secondly, when processing time will take a lot of memory. So suppose there is a very big object and then you have to do a lot of processing which will take a lot of your memory, and then you are trying to create an object. This is a very heavy process. It will give you a lot of memory issues. Then you have to just clone it and return it back. So what can be done? We can actually cache the object and return the clone of that cached object back, and not the cached object itself. So it's a very important interview perspective. It may ask you if you have create a cache map with a key value pair, will the same instance be returned every time you give a next call? So I've already shown you with the running thing that no, it gives you a different instance because a clone method is called, and the clone method is nothing but a clonable super.clone. So this gives you a new object of it. That was enough about the prototype design pattern. This is the last design pattern that I'm covering, which is builder design pattern. It is very difficult. You please put a lot of concentration into this particular thing. And this is the last design pattern which we have in creational design pattern category, broad category. So what is builder design pattern? So the basic approach is that if you have a very complex object to be created, the builder design pattern says that you don't have to create the whole complex object at once, at a single shot. You can divide it into creating a step-by-step process, and by the end of using all those steps, you will get your complex object automatically in a very simple way. So first, for this design pattern, you need to understand, does your project actually needs it? Say suppose for example, I'll give you one real-time scenario. Okay, suppose I have to create a home or a building, but I need to create the building which is specific to location. Say suppose there is very earthquake prone area and there is one flood prone area. So I don't want the flood prone area or home to be created in the earthquake area, or similarly the earthquake prone area should have a flood driven construction. So that is why my home creation is very complex. Creating a home specific to locality is very difficult or very complex product at the end product. So what you will do, you can find that yes, my end product is a very complex object. So what you will do, you will create a builder class. The builder class will actually define ways to create all different types of home. So my builder will usually be a abstract class or an interface which will say that all homes should have floor, walls and terrace. Then there will be concrete builder. So it's like first builder will be the basic builder. This will be the concrete builder, which will be the specific builder. So if I want a flood driven home, so I will be calling the concrete builder who is actually specifically named for the flood driven home management. Similarly, for earthquake driven thing, I will be calling the concrete builder who will be having the specification to build flood driven homes. Now there will be fourth role, which is a director. So I have builders, I have builder of builder. So who will actually manage all these builders? So the director is the one who controls the object creation. So two main goals of this is to call the correct concrete builder and to return you the complex object. So as a client, you will call to the director. So real-time scenario, you are a client, you want a home. Now you give all the contract to a director. Now creator, this director will do two things for you. First, it will find the real concrete builder using your location. So suppose you are living in the area where there is lots of flood. So it will call the real concrete builder who is good in creating the flood driven homes. Or if you are in a earthquake driven area, it will call the concrete builder which is right for creating the earthquake driven home. So this is the responsibility of director. So you will go to director will go to the builder, and builder will actually create everything for you. But at the end, hand it over to director, and director is the one who is responsible to return you the complex object. So do you understand this flow? I'll show you with the Java classes now. So this is my builder design pattern. So I have told you what my home is a complex object. My home will have some common things: floor, walls and terrace. Now I will have one, I'll be a client, right? So this is my main class, my client. I will call a director using what is my area? I lives in an earthquake driven area. So I want earthquake resistant builder. So I will say, please director, go and bring the builder which is good for earthquake resistant building. So this is the work of director, to go and call this builder, contact him and manage the construction for you. It will manage all the construction and at the end it will return you your home. So can you see the two things it does for you? It manages your construction and return you your home. So this is the one person or one director which will actually do everything for you. So what this director really is in your class? This director is nothing but it will have a constructor. This constructor we have used as a client to say, where do I live? I live in an earthquake resistant area, earthquake driven area, flood driven area. Hence, it will call the earthquake resistant builder or flood resistant builder. Using that, then it gives you the complex object, it will return you the builder and it will manage your construction. So with this builder, it will build floor for you, it will manage all the required construction, it will manage your floor, walls and terrace. But this is not the one where I can see my real thing, right? What it does is, this is actually earthquake builder, right? So this is one builder. Builder will have nothing but the specification, how the basic things will be: build floor, build wall, build terrace, and it will return you the complex object. So director actually in turn interacts with this builder. So can you see, my main class interacts with the director, director interacts with the builder, and builder says that builder into this builder, this particular builder is nothing but an interface. So you have two different type of builders. The first builder is earthquake resistant builder and second builder is flood resistant builder. This earthquake resistant builder says floor should be wooden, wall should be wooden and terrace should be wooden. So it should be the earthquake resistant. I am not that particular civil engineer for you, but I just given you some implementation out of it. So it says the home should be earthquake resistant home and it returns you this particular home. While the flood resistance says that the floor should be 10 feet above the ground level, the wall should be water resistant and terrace should be water leakage resistant. So I am the client, I say I live in earthquake resistant area. So director says, okay, I'll manage the home construction for you. It goes to the builder, it gets the builder object. It says that my type is, I want earthquake resistant. It says that, okay, now if you have this builder with you, what I want you to do is to manage my home construction. So it will say, builder, go create the wall, floor and terrace. So since my builder type is earthquake, so it will go into wooden wall, wooden walls and wooden terrace. Once it has managed the whole creation, it will get back to director. Everything is done. I have managed your home. So what will happen? I will say, okay, since you have managed my home, now give me my home back. So it says, okay, now builder, get the object. Now with this object, you can get, since it is a interface, I'll get into this because it is the implementation and I've used this implementation, it will return me the earthquake resistant home. So this earthquake resistant home, if I say, tell me about the floor, it should be a wooden floor. So how do I make sure that I have implemented it correctly? I'll run this for you. And its floor should say it is a wooden road, wooden floor. So yes, it is a wooden floor. So can you see how builder is designed for you? What are the steps? I will make you go through it once again just for you. Create a simple Pojo. So I have created home for you. So this is my home, simple Pojo, which is a complex object I want to create. Now create a builder interface. I have created a builder interface for you. This will be used by director. Then you have to create a concrete builder. So this is a simple builder. It will create floor, walls and terrace for you. But there will be specific concrete builders, which means the concrete classes which will implement your builder, means the specific builders for you in the real world. It will develop either wooden floors or it will give you a floor 10 feet above the ground using the slits. Then you will create a director. The responsibility is there are two basic responsibilities: calling the correct concrete builder class, and the first thing, the concrete builder class. Yes, it is calling the concrete builder class. See here, the concrete builder class. Second is to manage your particular construction and give you the home. So these three things will be done by your director, and your main class will initialize your director, call the method for finally, and then you will have your particular home in your place. So I hope this particular design pattern is clear to you. If you have any doubt, because this is very complex thing, if you want me to give you the flood resistant also, I'll give you the whole code base. Just let me know in the comment section. I'll give you all the design patterns implementation. If you let me know in the comment section. That was all about the 5 design patterns we have in creational design patterns under this factory, abstract, builder, prototype and singleton. I've done my job. Now you have to tell me if you want me to cover the behavioral structure of J2W design pattern in the next video. I'll cover only and only if you let me know in the comment section. Thank you.